Hi, welcome to my channel. In this video, I'm going to step through how to code a game of Snake. While I do this, I'll display what the game looks like when it's finished. My goal is to keep the code as simple as possible. I will achieve this in two ways. First, I'm not going to use classes. Although I find it easier to create a program with classes, I realize some people don't like working with them, and classes can make what is a simple program seem more complex than it is. So, no classes. Also, this program has only one code file. Well, I do have another file where I keep the constants, but everything easily fits into one directory and should be easy to download. Before we look at the code, for anyone unfamiliar with the game of Snake, I'll explain how it's played. As you likely know, the goal of the game is to make the snake as long as possible. The snake grows each time it eats food. Also, the player gets a point. The game is lost if the head of the snake goes out of bounds or if it touches itself. When a piece of food is eaten, another piece of food appears at a random spot on the board. Now, a bit about implementation. I've created this game in 5 stages, where each stage adds functionality. So in stage 1, the snake moves from square to square. At this point, it's just one square, so it doesn't really look very much like a snake at all. The snake will be able to move from square to square, but it will stop after each move, so it won't glide across the screen yet. And also, the game will end when the snake's head goes out of bounds, but the player is not going to be notified of that. In stage 2, the snake will move smoothly across the screen, and the player will be notified before the game ends. In stage 3, food is introduced. In stage 4, the player is asked if they would like to play again. Also, the reason for the game ending will be displayed, so for instance, if the snake goes out of bounds. And in stage 5, the snake will grow each time it eats food. Because of this, an additional ending condition will be introduced, so the game will end if the snake's head touches its body. And also I've put an index in here, as you can probably see, so you can just skip to whichever section of the tutorial you're most interested in. Alright, that's it. Let's get started. This is stage 1, and this is what the game looks like when you play it. Here's the bit of code that starts the program. So as you can see there, keep looping is set to true, and we put the snake coordinates like snake x and snake y. We divide screen width by 2, and so the snake will be approximately positioned in the center of the screen. We initialize Pygame, and we draw the font, and that's an essential piece of code that you have to set the mode for Pygame. Also, we set the caption. As you can see there, there's the constants file, and that's the title. And then we initialize the clock, which we'll be using quite a lot. That's all not going to change throughout the stages, so I'm not going to go over initializing Pygame again. As you can see, the first 3 lines set variables that control whether the main while loop will end, as well as where the snake will initially be drawn on the screen. So there's the while loop, and first you can see that a handle events is called, and here's what handle events looks like. If you have any familiarity with Pygame, you'll notice that this is a bog standard handle events function. For every event in Pygame, we look at whether specific events triggered it. For example, we ask whether it was triggered by someone closing the window or pressing the escape key. If it was, then we set keep looping defaults, and as a result, the while loop will stop executing. By the way, notice that in the first line of the function, we declare 3 variables with the password global. This means that any changes made to these variables will be reflected outside the function. And yes, this means that these 3 variables are global variables. And yes, global variables should be used with extreme caution. But here, since this program is very small, and since many of the functions are related, it works out fine. Now, let's look at how the program handles movement. When the player presses an arrow button, the snake's X or Y variables are changed depending on the direction we want the snake to move in. Okay, so back to the while loop, and now we are going to call the draw function. Again, all this is pretty standard. So there you can see the draw function. As you can see, there is only one global variable here, the screen variable. First, we fill the drawing surface with white. We then draw a rectangle that represents the snake and update the display. On the last line of the while loop, we check to see whether we should end the program. We do this by checking to see whether an end condition has been met. At the moment, there is only one end condition that matters. Has the snake gone out of bounds? So depending upon whether the snake's X or Y values have gone out of bounds, We either set keeping to false or make no changes. If keep looping is false, then the while loop exits and the program ends. Although it isn't strictly required, I like to call Pygame quit and sys exit to make sure that everything that should be closed down is. Okay, now let's go to stage 2, and here we implemented smooth movement of the snake and including text in the program. So as you can see, the direction variable is new. We need it because the handle events function has changed. Instead of adjusting the snake X and snake Y variables directly, we just set the direction we want the snake to travel in. And now, every tick of the clock, a new function, move, is called. This means that at every tick, either snake X or snake Y is adjusted. And as you can see, that gives us relatively smooth movement. Another change to the program is that the player is now notified before the game ends. The goodbye function there is new, so let's take a look at it. As you can see, all we do here is write a simple message to the screen surface, in this case just game over. I want to display the message at the center of the screen, so I figured that out and put the desired numbers in the I and J variables. I then use these variables to position the message on the surface of the screen. Now, when the Pygame display update function is called, our message will be displayed. So far so good. We have a snake that glides across the playing surface, and the game will end if and when the snake glides out of bounds. And also, when the game ends, the user will receive a notice of that. But this is early days. We still need to introduce something for the snake to eat. And that brings us to stage 3, food. As you can see, I've introduced 2 other coordinate variables, food X and food Y, and initialized them to -1. Also, for this version of the program, I introduce a new variable, player1. This won't be needed in the final version of the program. Here, however, there is a clear end condition where the player wins when the snake eats the cheese, so I thought it would be fun. Now let's look at how the snake finds the food. Let's take a look at the spawn food function. As you can see, the first thing I do is declare food X and food Y as global, so that any changes to them will be reflected throughout the program. Then, using the randint function, a random number is chosen between 0 and the screen width minus the width of the tile. This will ensure that the food will never be displayed off the viewing surface. The draw function also needs to be adjusted. As you can see, that's pretty easy to do. The biggest change takes place in the end condition met function. You can see there, if snake ate food equals true, then keep looping is false. As you can see, here we call a new function, snake ate food. If this function returns false, then keep looping is set to false and returned. Here's the snake ate food function. Okay, so there it is up on the screen. As you can see, all I'm doing here is checking whether the current XY variables for the snake are within the food coordinates. If so, then the snake has touched the food, but if not, then not. That's almost it for the third stage. All that's left to look at is the message that tells the player that the game is over and whether they've won or lost. If player 1 hasn't been set to false, then that means the snake has eaten the food, which means, as I've set things up, that the player has won. To display this message, I use the text message function, and let's take a look at that. This is just the goodbye function, renamed, but with the ability to specify not only the text, but also the color of the text. Okay, now let's look at stage 4. The big change in this stage of the program is that rather than quitting after an end condition is met, the player is asked if they would like to play again. If the player responds in the affirmative, then the game is reset and the player begins a new game. If not, then the game ends. This was the old while loop that served as the game loop. Now, as you can see, I've changed this part a bit and made it a proper function called, somewhat predictably, main. Since the main while loop is now a function, I need to make keep looping global so that the changes made to it will be reflected in other parts of the program. So first, I set keep looping to true, and a reason is set to an empty string. And then I call the spawn food function so that the rectangle that represents the food will be positioned correctly when it is drawn on the screen. I've stepped through that already, but here the code is again for reference. As you can see here, this is the end condition met function, and it contains the first significant change. A variable, a reason, has been added, and we assign a bit of text to it depending upon which end condition obtains. The variable is then returned and given to a function we haven't seen before. I hope that's clear. Okay, so now let's look at the player being given a choice whether they will play again. There's the main function again, and here is the brand new continue playing function. Now that may look a little complicated, but it's not. This is actually a mini game loop. What I'm doing here basically is implementing a dialog box without using a class or spawning a separate window. And I've gone through how to implement a dialog box in many of my other videos, so I'm not going to talk about that in this one. I'll leave a link to another one of my videos that deals specifically with dialog boxes. Okay, let's step through the continue playing function. Now, depending upon what the reason is for quitting, a different message is displayed. Independent of that, though, the player is asked whether they would like to play again. There you see line 1, line 2, and line 3. These lines of text are rendered onto surfaces. Each surface will be placed at different coordinates, and I want each line placed at the center of the screen. Since the drawing surfaces have been prepared, we will now enter the while loop that will display them. The player can do one of two things: quit the program by pressing escape, by manually closing the window, or by pressing N. The player can also choose to reload the program and play again. That is accomplished by pressing Y. And that's it for stage 4. So finally, stage 5. We're going to do quite a lot here. First, we're going to implement another end condition. We're going to check to see whether the worm's head has touched the worm's body. We're going to display the player's score. We will also have the snake grow. We're going to keep track of the high score, and we're going to draw the head as a different color. Let's get started. So far, our worm exists only as a head. That's not very good. Let's give it a body, one that grows a section or segment every time it eats food. And now, here's how the program begins. Notice that before the while loop is entered, the high score and keep playing variables are initialized. Then we grab the high score from the file highscore.txt. And there it is in the file system. After that, we get the XY coordinates for where we want to initially draw the snake's head. We do this the same way as in previous versions. Also, the direction is set to none. I'll explain this in a moment, and then we call our main function that is aptly, if somewhat unimaginatively, named main. Let's take a look. First, we declare keep looping and snake as global variables and make sure that keep looping is set to true. Notice that we declare the variable at reason here. This is because we will need a reference to it outside the while loop. The first function that is called is spawn food. We've seen this function before, so I won't go over it line by line. Next, the main while loop is entered. As you can see, I've set the clock to no more than 10 frames per second. And yes, this is rather slow. If you would like the game to be more challenging, try maybe 20 frames per second. Since the handle events function hasn't changed, I'm not going to go through that. One function, though, that we need to step through is think. Here's how that function starts. And notice that right away we make snake global. We have to do that because we're going to be changing the contents of that variable and we want it to update throughout the program. Now let's look at the snake variable. If it has more than one section, we indicate for each section that none of these sections are heads. So essentially we decapitate the snake. And I do this just because I want to make it clear which section is the head. Now we want to move the snake. So right now I would like to talk about direction and why it is initialized to none rather than a direction like up, down, right, left. This code shows us why. Notice that the only time direction will be none is at the very beginning of the program. I did this because I didn't want the snake to move until the player depresses an arrow key. And every time an arrow key is pressed, then direction will be set to either up, down, right, or left. So after the direction is recorded, I create a new directory object that I've called mydict and make it the snake's new head. Notice that the x and y variables position the head on the screen and that they are set equal to the snake x and snake y variables. Okay, so let's go back to the think function. As we've seen, the move function passes back the newly formed snakehead and puts it in the variable called new section. The first thing we do is give the poor snake a head again. Then, if the snake has collided with the food, we need to spawn the food in another location. We've seen this function a few times before, so I won't go over it. If, though, the snake didn't find any food, then the snake's tail, and that's what I'm calling the last section of the snake, will need to be removed. Now, I'd like to take a time out and say a few things about the logic of what I've done here in terms of the snake's movement. If you've never played Snake, you might wonder why I've done this. One of the cool things about the game of Snake is that the snake doesn't ever move, really. It's an illusion. All that happens is a new head is created and placed on the body, and the lastmost section of the snake, the end of the tail, is taken away. Since this is done quickly, it looks as though the snake is one thing and that it actually moves across the playing surface. Really, it's just being assembled and deassembled. None of the snake's sections actually move. So really, the way I've implemented the game, I don't have to do anything extra to get the snake to grow. All I have to do is refrain from moving the end of the tail. That's it. Easy peasy. That's how the snake grows. But of course, the snake doesn't usually find food. When the snake doesn't find food, we do have to do some work and remove the last section of the snake. So we call the function remove tail, and here's what that looks like. Since the section of the snake with the lowest index will be the section we want to remove, all we need to do is find the lowest index and then use that index to assemble a snake with all the existing bits except for that one. All that is left now is return the new list. So we're back in the thing function. The remove tail function has just finished executing and the snake variable holds our updated snake. So back to the main function. The next thing we will do is call the draw function, and this is mostly the same except that I've tweaked a couple of lines so that the head of the snake is colored red while the body sections are colored black. You don't have to do that, I just thought it was kind of cute. So that's pretty straightforward. Of course, you can make the snake's head any color you'd like. You could even try generating a random color. Now, as before, we call the end condition met function. And here's what that looks like. Only one thing has changed since last time. Now we also check to see whether the snake's head overlaps with any section of its body. If the snake's head does overlap, then continue loop is set to false and the reason variable is set. Here's how I check to see whether the snake's head is touching any of its sections. It's pretty easy. So first of all, I get the head of the snake. Since only one section of the snake has the head field set to true, as soon as that conditional is true, the corresponding section is returned. I could have probably gone with also what is the highest index, but I just thought I'd look for the head. All that is left to do is go through each section of the snake that is not the head. Of that section, we ask whether the x and y coordinates of the section match those of the head. If they do, then true is returned. If the for loop finishes executing and no matches have been found, then false is returned. And that's it for that. So now we're back at the end condition met function. If the snake's head did touch a body segment, then we return false, and the reason why the program needs to stop executing. So that brings us back to the main function. As you can see, when keep looping is set to false, the while loop will exit and the continue playing function will be called. And here's what that looks like. As you might be able to see, the code hasn't changed since stage 4, so I'm not going to go over that. Anyway, so now we're back at the code that started everything off. Note that if the user pressed Y, then keep playing would have been set to true and the if condition would have been satisfied. If the current high score is higher than the recorded high score, then the current high score is recorded. And then a new snake is created, although, it's just one little square, so it's only a head, and the game resets. On the other hand, if the player pressed N, then the goodbye function is called, and the game ends. And that's it. Once again, here's what the program looks like when it runs. If you have any questions or comments or suggestions, please leave a comment and I will get back to you. Thanks for listening and good coding.